Free audio post-production by alphonic.com.
All right. Well, good evening, everyone. Welcome to the October 2025 edition of the Garden State Java User Group meetings. Hopefully everybody survived the nor'easter we just had. So I know, unfortunately, the Jersey Shore got hammered a bit, but I think the rest of the state fared out fairly well. So thank you for making the time to come out tonight. We have a rich agenda tonight. A really big shoe at everybody out there in television land. So I just thought of this a few minutes ago. I don't think I give enough credit to the folks that are doing all the behind the scenes stuff. I know Barry, myself, and Paul in the back. We're three of the directors. We have Diane in the back as one of the leaders of the three leaders that we have. And we also have an advisory board. There are folks from the outside of our organization that meet with us every other month, thereabouts. And, we tell them what's going on. They give us ideas and, some guidance. And this is a good thing. So this, for the last 5 years, under the Garden State Java User Group name, it's been a lot going on. I'm grateful for the way things have been going the last 5 years. As you may know, we operated for almost 20 years under another organization. So we'll be hitting 25 years in February. So stay tuned on how we're going to celebrate that next year. So thank you to the leadership team for everything you do. And let's go for another 25 years. All right. So our agenda, as always, if you've been here before, you've seen this. We always thank our sponsors. Talk about what's new. We'll have the lightning talks with Logan, Chris, and Thomas, maybe not necessarily in that order. I'll let them work that out. And then we have Harry Kimple here from New Relic, who will talk about tracing events. Yeah, using observability. I forget the exact title. And then after the presentation, after Harry is done, we'll just talk about some upcoming events happening for us. All right, so real quick. So Payara is our gold sponsor. As you know, they make the Payara platform, which is Payara Server, Payara Micro, and they also have a Kubernetes type platform and Payara Cloud. So there's some news happening there with that. It's under embargo at the moment, so I have to keep my mouth shut. Our server sponsor is Azul. They make a downstream distribution of OpenJDK, and we'll talk about that in a couple of minutes. Our partner is DevNexus. This is a conference that happens once a year in Atlanta, Georgia. It's in early March of next year. Barry, myself, Chandra, we've all been presenting at this conference. They also have a summit for Java user group leaders and for Java champions. All right, so we have a particular October 2025 sponsor, it's actually Confluent. They wanted me to use the Kafka logo, but we have to give Confluent some recognition. They covered the cost of the pizza and the soda tonight, so we need to thank them very much for that. And it was great working with them to get all that arranged. So thank you very much to Olivia and Shay. Our per meeting sponsors, Romanelli's is our pizza place. We also have with Firehouse, which both are in Madison here. JetBrains, of course, provides the licenses for IntelliJ IDEA, and the Eclipse Foundation and Jakarta EE does provide hosting for streaming. I guess streaming hosting. Can't think of the actual word here. So we thank them for that. These are our memberships. We're part of the Jakarta EE ambassadors. Also, we are working group members, guest members, more accurately, with the Microprofile and Jakarta EE working groups, and also with Virtual Jug. And then Payara, they've done some podcasts. They are sponsoring a number of Java user groups. And I forgot to mention, they had recommitted their sponsorship for next year. So this was just recent news. So we thank them, of course, for their support. But you can take a listen to these podcasts. They happened earlier this year. So if there are any more, then I'll make sure I put them up there. Okay, what's new? As I mentioned before we went on the air, we're going to celebrate 25 years in February. And I think we designated February 17th as a remote celebration, as a remote meeting separate from a normal meeting like we're having tonight. So stay tuned for details on that. Here's Payara Cube. So this is one of their new offerings that they debuted back in June at one of their virtual Payara conferences. And then they partnered up with Azul, for working together for doing applications development. All right, JDK 26. But you'd say, Mike, JDK 25 was just came out. It did. But JDK 26 is well underway. These three JEPs, or JDK enhancement proposals as they're known, their features, they're already targeted for JDK 26, which will be released in March. And I have the release schedule. This was just made as a proposal. It should have been finalized by now. But anyway, so ramp down phase one is when the feature set is frozen. So no more features for the language. And then it goes through some release candidate stages, and then it'll be March 17th of next year. It's the same week as Java 1 2026. Okay, so as I mentioned before, JDK 25, I'm not going to go through these in detail. There were 18 of JEPs or features. Jakarta EE 12. 11, as you know, was released in June of this year. For 12, there are 24 of the specs that are going to provide updates. Jakarta Query 1.0 is brand new spec, and it was just elected or voted to include in the platform and the web profile. So this happened fast, and I know the folks on that spec team. They will have everything ready for Jakarta EE 12. And so there was a vote on the steering committee. Anybody can vote, but only the working group members' votes count. So the community can participate in that. Jakarta Portlet and Portlet Bridge, these were migrated over from the Java JDK specification request, or JSR, that was put out in Java EE 8. Most likely, they will not be part of 12. There's a lot of work to do that migration. All right, so what else do we have? Oh, so we have the three students. They're going to go first, but I don't want to have to flip back and forth to the slides. So I'm going to introduce Harry. And Harry, you think you reached out to me in July of this year. You reached out to me through Meetup. It would behoove us to actually look at these messages a little more often. So it was like a month later. I'm like, oh, so anyway, Harry is here for a conference, and he's with New Relic. So let me read his bio here. So Harry Kimple is passionate software craftsman with 28 plus years experience in a broad spectrum of software development technologies and platforms. His main focus is on cloud-native software architectures and all major cloud environments. He has a passion for model-driven development, application modernization, and distributed application runtime. Observing and securing these environments are key aspects. As a developer relations engineer at New Relic, Harry helps software engineers, DevOps, SREs, and operations experts to understand and implement proactive and scalable observability practices by leveraging open source technologies and the New Relic platform. So let's welcome all four of our guest speakers tonight. So we have Logan. Where's Logan? There he is. Logan, welcome. We have Thomas. There he is. Okay, very nice and dapper, And then Chris, who's right in the front row there. And then, of course, Harry. So let's give them all a warm welcome. And I'll keep my mouth shut now and sit down, which is always a good thing. So, so whoever wants to go first of the students, please take it away.
No one phone.
All right. Good evening, everyone. I'm Chris Gibbs. Thanks to everyone for the invite to come and speak, especially Diane, who I've had the pleasure of knowing for several years now. So I'll do a brief lightning talk on, my perspective as an engineer related to data in the business world. And so, just before we dive into that, a little bit of background on kind of my journey and where I started, how I got here, and what sort of things I'm doing nowadays. So I actually grew up in Michigan, and then I did my undergraduate in the Upper Peninsula of Michigan at an engineering school. So I got my bachelor's degree in mechanical engineering. I finished that in 2005. Yeah, 2005. So just over 20 years ago, entered the workforce and started my career. And that took me down to Southern Indiana, where I did 4 years at a manufacturing plant making sheetrock for a company called US Gypsum. So we'll talk a little bit more about that. But that kind of started what I kind of call now my first career, where I spent most of those years in manufacturing plants before I transitioned into the official data science, data analytics world. But data is all around us everywhere. So after 4 years in Indiana, then I went out west to Washington State and I spent 2 years out there at a carbon fiber manufacturing facility. That was a tier one supplier to Boeing. So making all the carbon fiber and the raw product that went into their aircraft fuselages, wings, tail assemblies. And then finally, I made my way over to New Jersey here, where I've been here for about 12 years now. And then I've worked for a couple different companies in this area. Spent about 9 years at a steelmaking manufacturing facility just off the Garden State Parkway in Sayreville. And then eventually I was able to transition over to data science. So just 1 year ago now, I finished and graduated from the master's program in data science here. I did that over 2 years. So I did that as a working professional, working full time, and then did the 2 courses a semester at night to learn Python, SQL, and R to kind of transition into a more traditional data science world, even though I would say I've been working in data my whole career. So that's kind of my journey of how I got here, and a couple little neat stories about data from my experiences that I think is fun to share. So, like I mentioned, the first place I worked was US Gypsum making sheetrock. So, anyone here ever lived in a condo or an apartment building? Anything that has a shared wall is a really kind of an interesting thing that just silently sits there that most people don't know about, but those all have fire protection barriers. And those walls are engineered and designed to sustain a fire for a certain amount of time so that if somebody has an accident in one room or one house, it doesn't spread and take out an entire building before people have time to react, respond. So one of my jobs working at that plant as a engineer and also a quality manager, come on in. It is the Java user group. Yeah, come on in. Grab a seat. Pizza, drinks as well. There's a couple of QR codes floating around if you wouldn't mind signing in, please. You no problem. You did it already? Yeah. Oh, well, we keep a spreadsheet with that too. But so one of my responsibilities there was actually partaking in the fire destructive tests on our product. So our product got shipped up to a lab, the wall gets assembled, and then it gets set on fire. And you get to watch the process burn, and then there's all sorts of instrumentation on the product. So that was kind of some of my first introduction to where is data really coming from and like what are the real things around us that are involved with data. So we had to make sure our product could survive this fire test. How did it fail? And then we would actually go back to the manufacturing facility and then make sure our product, was following all those specifications. And we had an outside lab that would actually come in, observe our process, and we would have to show them all of our data. So every single piece of equipment that was feeding raw materials,
that was running the production line, the kiln or the oven that actually dries the sheetrock to make it in solid 4x8 pieces that we can take in our trucks and go build walls out of. That whole facility and that whole production line is constantly collecting data on the millisecond level for a lot of it. Temperature sensors, pressure sensors, RPM, tachometers, anything that's moving, we had sensors for. And all that data would stream into our databases and just store all that information for us to be able to troubleshoot, but also to be able to prove that, look, we took our drywall up to a lab and did a test, and that was maybe 10 pieces of drywall. But our plant could make 10,000 pieces every 24 hours. You can't test all those. How can you prove that a process is stable and consistent, and anyone who's going to build a home, that's going to perform the exact same way as what we took to the lab? That all centered around what data did we have? How could we prove that? How could we monitor it? How could we make sure our processes were in control? So that was kind of some of my first introduction to data in kind of a fun and an interesting way, and got to see something and learn about something that's been around me my whole life. All right, so another fun data related scenario as an engineer that I've been around for, again, my whole first career in manufacturing plants. What you see here is a screenshot of an HMI, a human machine interface. That's kind of the digital interface between the process and the equipment and the sensors and what a person operating the equipment might be seeing and doing. And so this is another great example of, again, where's data coming from? How is it around us? And, you know, in the graduate program here, we do a lot of maybe querying databases or querying files. And that's great, but like where does that come from? So this is, I think, kind of fun to get to see and think about, how does all that data get into a table or the flat files that are generated? So this project, a little bit of background on that, was working to supply Boeing. We had a process. This isn't the exact pictures, but very similar to this. Basically, we would make big giant buckets of really, really sticky resin. And the more that we could get out of that, the more efficient our process was. So we had to do a whole project studying all the raw material that goes into this mixer. We mix it, we go through a 4-hour long process, and then at the end of the day, we have to squeeze it all out of that port. How can we get the last 2 pounds, pound and a half a pound out of there? Well, we had to study that process. And a lot of that studying involved HMIs and all the data that was coming out from there. Um, so what's kind of fun to think about is like, okay, this is maybe what a machine operator might see, where you have vessels with raw material storage, kind of that blue, red, yellow. That's looking at how much material do you have, but that's all on instruments and being recorded and logged. And so you could kind of maybe visualize this process is running. All these instruments are collecting data, but how is that data getting organized? So maybe in the back end on the database side, you'd have one table of just these storage vessels containing the information on the storage vessels. And then these are pumps here. Maybe you have another table of just pump data. And then maybe you have, these are pressure sensors on pipelines. So maybe there's another data table of pipeline pressure. And you can start to think about, how does all that information get organized and recorded 24 hours a day? And then as an engineer, to be able to come in and join all that data together, right? Doing maybe SQL joins or data frame merges to start to tie all that information together, to understand it and aggregate it and do queries over long periods of time. Um, so when I was learning this information and going through these projects, little did I know I was going to eventually get a master's degree to learn how to do all the programming to get that information. But I was working with people who were maybe querying that backend database, and it could help me collect all that data where I would actually know the equipment or go out to the plant and work with the operators to change the equipment, change the process settings, but needed to work with somebody who could help get me all that data.
Yeah. So yeah, a couple of quick questions. Is that LabVIEW perchance by
Uh,
National Instruments?
so this is just a screenshot
Yeah.
from a random website. I mostly dealt with like some Allen Bradley equipment.
Okay.
Most of my career, I've used LabVIEW a little bit,
Mhm.
but Allen Bradley commonly is Bradley or
Mhm.
Rockwell Collins.
It's probably a competitor to LabVIEW, I imagine, because
Sure.
my career at Exxon, that's what they used in the laboratory.
Yep.
And then a question about the resin in that
Yes.
instrument right there. Any rheology involved in order to make sure that the
I did a
liquid
whole
could?
lot of viscosity
Ah,
testing.
lovely. Yes,
So
yeah.
you know some rheology work.
I've done a lot of rheology work. Yeah,
Yes.
yeah. We have to
Yes.
talk later.
So for anyone who doesn't know, rheology is the study of viscosity or resistance to flow. So how viscous is a resin was a very critical specification in our products. Um, this product was going on the Dreamliner. So the new wings, the new fuselage that the 787 Dreamliner used, we made several different resins for them. But yeah, the viscosity is highly critical in that manufacturing process.
Cool. Thank you.
Yep. Okay, so there's just a couple examples from my manufacturing career and life. And then once I started the data science program here, when I was about halfway through, I actually was able to transition out of manufacturing and into a more traditional data science realm. And I got a job at NYU Langone Health over in Manhattan, working in the supply chain in the data warehouse. So our team is responsible for all the data that we use within the supply chain. Um, so I'll just show again a couple real examples, real problems to solve that I've dealt with there that I've directly been able to use our Python programming that I learned through this program. So this is an end state output. This is an automatic email that I generated for one of our projects where we need to automatically update a table and update a report, and we want to know, did our process work? Was it successful? And maybe some additional information. So this is just an example of it's an email that goes out, but I built all the Python code to be able to construct and generate this email where there's dynamic information here, right? The number of rows on the table. So we query the table, find the rows, dynamically put it into the email. What date did we last update it? It's an old screenshot. How long did it take? When did it start? When did it finish? So real life examples of like what's some important information we need to know on the business side, but on the back end side, how are we actually going to construct that and build that and send it out automatically? Hopefully that's big enough. So just an example. So that's actually just one of the functions in Python, right? And this was, I would not have been able to do this had I not gone through the program here. Right? I spent my whole background was an engineer. I was changing processes. I was testing equipment. I was buying equipment. I was starting it up. I was working on failures. And so I thought logically, right? If then was my whole world. And I did a whole lot of controls engineering, but I was never the person writing the code. So now I'm actually getting to write the code and build the functions and build the program that's executing things to solve our real world business problem. So well documented, nicely readable, well structured, well formatted, all great lessons that you learn in class brought over to real world business problems. Another good example, another process that we want to automate. Some people on our leadership team want to know a monthly update on a process that we have where we manage items. And so they wanted a dashboard. So, okay, great, no problem. We can build a dashboard with the data. I don't want to have to deal with going in and updating that every day, every week, every month. So how do we go about doing that? So this is again kind of end state. Here's a Tableau dashboard showing the data we want. It answers their questions, solves the business problem. How do we go about actually building that where I'm not having to manually do that every day? Kind of working backwards. That was the dashboard. That dashboard is linked. Same concept in this automatic email that goes out. This is a monthly one, right? So this job runs once a month. We update a table. We send an email. We include the link automatically to the dashboard for anyone who might want to see that, know about it. There you go. Kind of using some of my process engineering background, also some of the lessons that you might learn in some of the classes of like sketch out how are you going to go about solving your problem. And I've always found it super beneficial to work backwards, right? The end goal was these two pieces. We know we wanted an automatic email. We know we wanted a dashboard that's updated. How do we go about doing that? Okay, well, to feed the dashboard, we need to have a SQL query that we're extracting the data we want, that the data is formatted for the dashboard, and that it's just sitting there in a view and the dashboard can just read directly to that view. How do we go about getting that data? Well, I got to make sure I got the right data in the right table in our SQL server. How do we get that data? That's actually coming from a raw flat file that once a month somebody would download a file from a website. And so we need to read that directory, find the file. So that's kind of like the working backwards process that I found to be super helpful when designing solutions in the business world, where I'm going to need to have like some structured methodology and then put some automation to it. Okay, quick lightning talk, couple examples from the manufacturing world, couple examples from the more traditional data world that I'm working in now. Yeah, it's been a great journey. What I've learned the most is if you can answer the question, what problem are you trying to solve? You're going to be more successful, but you're also probably going to enjoy the work you're doing, definitely in jobs, but also just through class of like, how can you find ways to solve a problem and to kind of tell yourself that story or find a story in the assignment of what are you trying to solve? On the career and the professional side, right, I've tried to kind of show the message that careers are a journey. You don't know where you're going to go. I certainly never imagined I was going to get my master's degree in data science. Love that I have. It's been an absolute thrill for me. I've learned a lot. You just never know where you're going to end up 20 years into your career. And through all that, pay attention to what excites you and what bores you, and try and shift that balance to more excitement and less boring. You might not, probably won't ever get to 100 to 0, but the more that you can shift that balance, the more you'll enjoy things. Questions? So besides rheology, anything else that anyone wants to talk about?
Yeah. I just think it takes quite a courage to change career of 20 years, right? So what was let's say the number one motivation that like you had?
Yeah, it was really due to the plant where I was working, got taken over and got sold to another company. And so just kind of during all that transition, there was a lot of time to think about what do I want to do? What excites me and what bores me or what stresses me out. And I had a lot of time to just reflect on that and think, I loved the part in all those plants that I loved the most was doing the process engineering and like the solving the problems with the data. And I thought, how do I do more of that? And I live about 15 minutes from here. And I knew there was a data science program here. And so I thought, well, why don't I start to learn that and see if I can do more of that. And like I said, I kept working full time. So I still had a job, I still had income, there was a good safety net there. And then this program was great to be able to do at night, 2 classes a semester to start learning it and seeing if I liked it more. And I loved it. And so once I got halfway through, I just started applying for jobs, and it's worked out really great. I didn't realize then how well my prior experiences would transition, but they've been super helpful in transitioning over, because it's just so much logical, structured problem solving. And that's really what I did for the first part of my career.
So, go ahead. Say you're a college student here looking to change focus. How how would you like tell them? Like, what would you say to them to I guess inspire them or excite them about changing focus between the visions?
Yeah. Look, change always has some risk associated to it. So it's just one of those things that you got to reflect and think about. Is that worth it? Why do you want to change? Are you running from something because you're scared? Or is it because you actually found something that you love and that you enjoy more? And so I would reflect on that a little bit. And if it's because you want to pursue something that you just get more enjoyment out of, I've always been a big believer in like, go do the things you enjoy and good will come from that. Because when you're doing the things that you enjoy, you just have better energy, you're engaged, you're interested, and like, you just, you want good things will come with that. It's not going to be perfect. There'll be challenges for sure, but hopefully it tips that scale more in favor of the good versus the bad. Eric?
Yeah, not necessarily a question, but like more a statement. I mean, you said the program took like 2 years.
Yes.
So it takes courage and dedication to actually do that, full-time work and, learning and, studying at the same time. Huge respect for that. I mean,
Thank you. Yeah, there was definitely some long days and
Ugh.
some challenges. But kind of to that question, I was seeing that I was really enjoying what I was doing, and that helped make it feel less overwhelming. Yeah. Yes.
You took a big pay cut when you started your new career.
Yes, but
You weren't supposed to say that.
well, let me qualify it. So at the steel mill, I was a production manager of a 90-person team of a 24/7 operation. So it was a big job, big responsibility with a whole lot of stress. That brings pretty good compensation and big income. The job I took is still a very good job, very well paying, but yes, it is a pay cut, but I have an immensely better work-life balance, way lower stress. Steel mills are also incredibly dangerous. So I'm not dealing with people like potentially getting killed every day. So, not everything's about money. There's definitely a huge trade-off in stress, work-life balance.
All right. In the interest of time, let's thank Chris again, and then so Thomas or Logan, who wants to go next? All right, Thomas. All right, he raised his hand first. All right.
There you go.
Thank you very much. How does this work? Just right. So, hello. Thanks for inviting me to GS Jug. My name is Thomas Jenkins. My lightning talk is going to be on vibe coding and whether or not you guys think it's a cybersecurity nightmare. So, who is this guy and why is he here? I'm a cybersecurity and computer science major here at Drew. I started about a year ago, so I'm officially a sophomore. I'm also a embedded learning fellow in Diane's class, the Intro to Python course. I'm also a tutor for cybersecurity, Python, and Java. And this QR code here links to my website if you want more information on the stuff that I'm doing, the stuff that I'm involved in, or you can just visit the website there. That's a little bit of background on me. Let me also time myself. So what is vibe coding exactly? So I stole this off Wikipedia here. Yeah, I know that's not the best academic practice, but whatever. I'm not in an academic setting right now. So vibe coding describes a chatbot-based approach to creating software where the developer describes a project or task to a large language model, ChatGPT, for example, which then generates code based on the prompt that's given to it. So, you essentially just use plain English to feed into these LLMs, and it spits out a result. So, the traditional way of using LLMs, that you'd go to the website itself and you would put in your prompt into the text box, and wait, and it brings back a result. But nowadays, these LLMs are increasingly getting implemented directly into the IDEs, the development environments, such as here. This is in PyCharm, and I believe it's also in IntelliJ, where you can just talk directly to the AI, put in your prompts here, and it returns an output straight in the application. So this would be something like a standalone AI chat interface. And another way that these LLMs and AI is being implemented into the development environment is through stuff like the autocomplete feature here, where you just put in a tiny amount of code, and you just press tab, and it spits out everything here. So I don't know how well it comes across on the projector, but all I typed here was website, and it prompted all this extra stuff as essentially a suggestion to put into the program. So these are the two types that I'm seeing right now being implemented. So, how is vibe coding, right? This prompt-based approach of software development being implemented in actual, development. So here's just an example from the Stack Overflow blog, from Phoebe Sajor, I believe is how you pronounce her name. She was at a hackathon, and she wanted to create an app just from prompts. And her idea was to create essentially a Yelp copy, but instead of rating food, you rate bad bathrooms. So here is this pretty nice UI, right? Of where it is, the city, address, and your rating here of the bathrooms. So this was made using Bolt, a big AI app development tool, and here's the result. So you put in some prompts, and out came the program. So here's some reviews from Phoebe. We got I got several error messages and scary red text, 45 minutes of troubleshooting, and the app doesn't work. So that's essentially what resulted from her efforts of putting in a prompt and trying to get an output that worked first try. Although while there are some negatives, there are also some positives. Bolt was a powerful helper. It would eventually deal with the issue if you kept feeding it its own errors. And largely the sentiment was, it all depends on how you use these AI tools, how you vibe code essentially. And talking about something called the productivity tax, which I won't really get into right now. She said AI tools, they spit out the code that is almost but not quite right. There's some gaps that need to be filled by the developer themselves. Here's the article. It's also listed on my website if you wanted to look at it. So, how does this relate to cybersecurity? In its current state, these LLMs, these AI, gives quite a bit of insecure code as a result. You tell this LLM, you say, hey, I want this app, and it'll give you that app, but the result, like the actual code in the app, is more focused on achieving the task, but not necessarily achieving the most security at the same time. So results can often be without input validation, sanitization, right? The cybersecurity suite, stuff that malicious users can use to do bad stuff. So I thought, okay, let me give this a shot. Let me try and use AI without any input from myself, from my own, and try and create a really simple network program just from AI. So this is ChatGPT. I prompted it with, give me some Python code that allows the user to ping google.com. And this was the result. So it uses the OS module. It created this function. And this function is secure. But it's only secure because it's self-contained. There's no user input. There's nothing else being fed into the program. You just call ping Google, and it pings Google. That's all it does. So I thought, okay, let's add a little spice into this. I followed it up with a prompt that says, give the user the ability to also ping a different website if they wanted to. And it returned this. And if you'll direct your attention to the big red underlines, you'll see some issues. We're taking direct user input and feeding it into the shell from these two lines of code. Here's the rest of the code that got cut off from the bottom. So we ping the website, right? User website. We're intaking user input with this, and we're passing it directly into the shell. So if you guys, if we're in a great world, that's fantastic. Works just fine. But it's really simple for stuff like this to be implemented into larger scale programs where, there could be some oversight, and a malicious actor could, I don't know, shut down the system, for example. They could shut it down. They could delete stuff. They could do all kinds of stuff if they have direct access to the shell, to the command prompt. So here's the result. I was able to pass in the command ipconfig into the program via the ampersand, and it pinged Bing, whoever uses Bing anymore, and then it ran ipconfig. So here's the proof that you can't pass stuff directly into the shell with programs like that. So it's essentially up to the developer at that point to identify this stuff and say, hey, there could be an issue here, right? So I thought, all right, let me try again. let me combine those prompts and say, give me some Python code that allows the user to ping Google, but also gives the user the ability to ping a different website if they wanted, such as Bing. And I don't have the results from ChatGPT, but you guys are just gonna have to trust me on this one. This is what it spat out. And this is more secure. It's more secure than what was given before. It's not vulnerable to the same simple, just concatenating commands from the last one. But there are probably vulnerabilities in this, some that I don't know about, but it is more secure than the previous example, at least. So I thought, okay, great. So we now have two different variations of the same function, right? We still want to do the same thing. Two different ways to do it. Let's see what happens if I ask it for a third time. I prompted it again. And it gave me something similar to the first example, where it takes direct user input, passes it into the shell, and Bob's your uncle. So that's that. Here's my program again, ping Bing. And I also wanted to run the ipconfig command, which I did, and it successfully ran. So then I said, but this is very insecure. Up to this point, the LLM, ChatGPT, was giving me these results almost instantaneously, right? Within 3 seconds. The moment I contested it and said, this is very insecure, it all of a sudden started thinking on what to do next. So after thinking for about 30 seconds or so, maybe longer, it eventually came up with this program. Oh, and gave a response. It says, yes, you were right. This is very insecure. It makes it vulnerable to command injection. Here's an example. And it lacks validation and all the other good stuff. So then it spat out this. Here is 137 lines of code to ping Google or a different website. Zoomed out approximately 85%, probably more. It's the most that Chrome would allow, and also that Google Docs would allow. And this is not all of it. It goes on to the next slide. Here's the rest of it. So yeah, 137 lines of code. Also on my website if you wanted to go look at it. So what do? You're a junior dev. You ask it for a prompt, right? Something that you don't know. You can either put in something that's incredibly insecure or 137 lines of fluff. What do you do at this point? Well, that's up to you guys to decide. That's why I asked the rhetorical question at the beginning. Is it a cybersecurity nightmare? Depends. Heavily depends. It depends on who uses it. It depends on who checks it, if it passes through, what the program is. It really depends. It depends on a lot of things. And for reference, here's my code to ping Google or a different website. I believe this is maybe 10 lines of code. And this does not have the same vulnerability as the code that ChatGPT gave. Now, it does use a module, but use a module or reinvent the wheel. I don't, you tell me. So what does this all mean for you and me? Current computer science students coming out of college, or are in college currently, are bombarded with, the promise of the future in AI, right? They're bombarded with these AI tools all around them that say, hey, I can make your life a lot easier right now. But maybe easy right now isn't the best thing, isn't the best idea. Maybe we need a little bit of tough stuff that you can only understand and see with practice, right? Because unless you know it, ChatGPT right now at least is not going to give it to you, right? If you see a vulnerability, you have to tell it that you see it, and then it spits out 137 lines of code. So if students coming out of college right now, they miss this stuff, serious consequences could occur. And I believe that computer science degrees across the country should be focused on using these AI tools because they are the future, right? They're not going away, but they should be using them as what they are, tools. They're not a replacement for developers. They're just tools, right? You can either use a screwdriver or a drill, right? A drill's faster, but you need to know how to use a drill. So yeah, it's completely up to the developer to ensure and understand security and secure coding practices, and they need to read the code that's being spat out to them in the first place to understand what's going on when they're using AI. And then people who do use AI correctly should reprompt for security when there's an issue, or in my case, just do it yourself, right? So that's where I'll leave you. Any questions for me? Yes.
So I did try that in the context, say, create visiting program, but you try to use existing module, but then would that give more positive context to make more secure?
It could, yes. I don't know if you can see it on this, but there are other modules being used even in this code here. So yes, this is more secure, probably. I didn't look at it completely because come on.
How can you craft the context so that it creates something like this?
You could probably specify it to say, make sure that you check for input validation, make sure you check for, you implement sanitization for bad input. And then just work with it as it gives you results in making the code more and more secure throughout iterations. Does that answer your question? Yeah.
What version of ChatGPT did you use for this?
The most recent one, which I think is 5 now at this point, ChatGPT 5. Yep. And now I will say something. The integrated AI tools like in IntelliJ or PyCharm, they won't even really it picks on quicker if you are trying to bypass its security measures. Like if you say, oh, make the user also, be able to ping a different website, it'll say, oh, I can't do that with the shell. I will use this other thing. But yeah, ChatGPT 5.
So let's do one more question if there are any more.
Yes.
Thank you for stressing me out.
Thank you.
But also, have you compared this to other AI platforms like Gemini or Copilot?
I've not, but in my experience, they're all very, very similar in usage. I would say that ChatGPT is the biggest out of all of them. So if it's there, it's everywhere. Anything else?
All right. Let's give Thomas a hand.
Spread and teach secure coding practices, please.
All right.
Oh, sorry. Oh, do I have that? Oh, yeah. There you go. Thank you.
Thank you. Wonderful trade right there. All right, so I do not have any slides personally. I feel like this presentation is better delivered just by speech. So let me introduce myself. My name is Logan Kleva. I'm a senior here at Drew. I'm majoring in cybersecurity. And I wanted to talk a little bit about taking your knowledge of computer science outside of the coding language, outside of the IDEs, outside of the computer, and being able to use it in either real life scenarios or applying it to further computer science principles. What I'm going to be discussing primarily is the use of it to get ideas further beyond. So I am part of the honors program here. So I'm currently in the process of writing an honors thesis. Professor Leipers back there is my primary advisor. So we've been having back and forth conversations about how to approach this, what the idea was in the first place, and how are we going to go about doing this. So when I first was considering an idea for an honors thesis, being a cybersecurity major, I had one of two ideas. It was either to look at cybersecurity sort of from a sort of philosophical standpoint about what are its implications, what good can come from it, what bad can come from it. And then there was also the context of writing up physical code for this. Although I've been coding a good amount of my life, I personally believe that having this much knowledge of coding and just being immersed in the computer science world, I feel like I should have the ability, I should say, to extract myself from the IDE and really put into perspective the ideas and the uses of coding in different ways. So in the thesis I'm currently writing, it is the difference between white knight hacking, straight up just illegal hacking, and not just what's good and bad about them, but where is the line between legal and ethical. So we all know that there are millions of cyber attacks that happen constantly throughout the world. Doesn't matter where from. We all know that these attacks are. And we need to figure out, okay, what are best practices to defend against these attacks? And this is where the white knight hacking comes in. I'm sure plenty of you may have heard of the term white knight hacking. If you have not, to give a very baseline construct of it, it is essentially hacking into something for an ethically good purpose. A good example of this is maybe you are an analyst for a company, and one of your parts of the job is to figure out where are weak points in these security protocols. That is where it is ethically correct to hack into something. We've all heard about the stories of these big companies having massive data leaks because of hacking, and that's where it's both ethically wrong and legally wrong. We need to think about the points where maybe it's not legally correct, but maybe it's ethically correct. Maybe, for example, exposing these big companies who are trying to make a quick buck on people who are in desperate need of help. Maybe some big pharma companies, for example, ethically or not. Sorry. Maybe hacking into them and giving out information may not be legally correct, but what if it's ethically correct? And I feel like that is somewhere, and that's what I'm discussing in my thesis. So I'm taking my knowledge of coding, of language models, of these security protocols, and applying it outside of the IDE, really making sure that I have these ideas harnessed and be able to describe them to a higher level and create some higher level thinking about that. And it's not just about, you can apply it to anywhere really. I know there are a lot of jobs that you have people talking about, oh, let's figure out where we're lacking, where are we strong. And those are situations where, although you may not be coding or writing code, you're still looking at it, you're analyzing it, you're going through and you're going, okay, what does this program do? What are its strengths, what are its weaknesses? And I feel like that is one of the best ways to take your experience of computer science outside of the coding space. Yes, it's fun to write programs. Yes, it can be very useful for job interviews, job applications, and even as a job. But we, as a group of computer scientists, need to extend our knowledge, not just based in the ideas based on the computer, but being able to vastly open our eyes to the different opportunities that lie within the computer science space. And that's why I believe that we need to take the experiences off the computer, off the IDBs, and harness it into a much larger picture. And with the knowledge that we have, be able to create an environment where it's not just the coding that's important, it's also the analysis of what's important.
So I happen to see an article today on Jerome Powell was saying he's got some bad news for people, that you won't be able to get a mortgage in certain areas like flood zones, or like putting fluoride in water, and some of these controversial things. There are insurance companies that know when everybody in this room is going to pass away based on how much Diet Coke they drink and all that stuff.
Now you've got me worried, Bill. And same here, because I'm drinking actual Coke, which is even worse.
No, it's better. But Chris put up Tableau, which is an analytics tool to do it. And I think Drew's program, not that it's beautiful because I don't think anybody else, any other colleges really have it. But there's a vast area of analytics where you're using tools like Tableau and so on to probe some of these things. The other thing that struck me in your talk is there are companies that do so-called penetration tests where they look at your website and see what the vulnerabilities are. But I think what you're talking about is more people can't buy mortgages and there's a lot of data out there. And I think there's a market for it, and I think you have a good thesis topic, and it's only trouble with it is it's bottomless.
If I may ask you, in your thesis that you're writing, have you thought about, and if you have thought about this, what type of criteria are you using to determine if particular hacking is ethical or not ethical?
So that is one of the, I guess, bigger problems with my thesis, or not really that it's a problem, that the term ethical can be thrown around and multiple people have several different definitions of ethical. I would like to say I want to keep my personal opinion out of it, but since we're talking about ethics, I feel like there is no choice but to include my personal opinion on that. I feel like with certain examples of where maybe it's not legal, but some people consider ethical, I may take public opinions of reactions to these kinds of hacking and kind of use that to interpret, okay, does the general public find this break-in or this hack, although maybe the hack in general is just not legally correct, does the general public see this and now it's okay, we understand why you hacked into this, and although maybe not legal, we're okay with it, or this is just flat out wrong, we don't like this, we're not going to stand for it. So I think I'm going to take both the general public and my personal opinion when it comes to
definition of habitable sense. I would say this.
Use and that's like, is there a greater possibility or not if I look at a private good versus a public good at some type of level of now that's just idea. Yes. So in thesis, are you like approaching it from like a morality standpoint, essentially trying to figure out like what is wrong as like good by human standard or by like you're saying like an ethical like legal standard by like this is good because it solves the legal problems, but morally just is like not good because it doesn't approach how the humans actually feel about this information. I think
People like feel like I'm going to also use moral as well in tandem with ethical because legal is very one-sided if it's is this fitting for the greater good of humanity? Is it for a good purpose? Is it not for a good purpose? So when it comes to comparing the idea, I will be using morals and ethics.
I once heard a story about a kid who found a cyber flaw in Xbox. Instead of just taking advantage of it, he reported it and they just gave him like a lifetime's free stuff.
So I guess that's a good way of pointing out, going back to using your knowledge there. That's an example of maybe some benefit that can come from finding this problem.
So taking advantage of it and use it like every cheat code he could find. He could have sold the program and made a lot of money by exploiting it, but instead he just did the right thing. There's that. See? Ethical.
Absolutely. All right. So, again, in the interest of time, we can all network after Harry's talk and talk some more about if you guys want to stick around. And by the way, for Logan and for Thomas and for Chris, we do have licenses of IntelliJ IDEA for you. That's a 1-year license. Are you guys interested in that? Okay.
I'd be in trouble if they said no.
Well, I know it's so we managed to save up a couple of licenses over the last couple of months to make this happen. We've done this before for our Jewel University students to give these lightning talks. So at some point I'll email you the coupons. One of them expires next month, so whoever gets that one, make sure you redeem it right away. So, but yeah, so this is our way of saying thank you for taking the time and present to our group. So. All right. Harry's up. Two more pieces, folks.
Should be doing like getting it right. It's about okay. Oh, there we go. Hello, everyone. As you can tell from my accent, I'm not American. I came over here from Germany, but I'll have more on that in a couple of seconds. What inspired me to give this talk is two things. There's two things that are currently happening. Kind of like more and more, we see the trend towards event-based systems in the industry, and that could mean any system like Kafka, which I'm using today, but also maybe Relic, other forms of event-based systems where, companies and enterprises decouple systems and use events to talk and interact and change messages. And the second one is OpenTelemetry, which I'm also getting into a little bit of what it is and why it is important. And it's also kind of like a huge trend in the industry right now, for a good reason, because we finally have agreed on a single open standard capture telemetry from application services. So this is kind of like the talk that I prepared for today. I have a couple live examples that I'm using in the slides. And if you have any questions, please stop me. So I am Harry Kimpel. I live in this part of the world, which is in southern Bavaria. This is almost at the border of Austria, so at the most southern portion of Germany. So behind these mountains is Austria already, and then Italy is like a 3-hour drive from my place, which is quite nice. I have always been in software, software development, software architecture. In contrast to Chris's journey in his life, mine was a little bit more boring. I always been in software. I started out my career is probably the wrong word, but I got interested in computers when I was 14. I worked at a gas station and saved some money, and then I finally was able to buy my first computer, which was a Commodore Amiga 500. And my parents were like, "Oh man, why did you buy such an expensive toy?" But for me, it was two things. Of course, we did gaming and we played a lot. I had two brothers, so we played a lot of games. But for me, also the interest in writing code into that. And back then, you had like magazines who printed code, and I typed it into the computer and played around with it and experimented. And that was how I started. Hey, this is interesting. How I can control what is happening in the computer. And after that, I wanted to learn everything about computer science. So I studied computer science at some point and have worked in software basically all my professional career. So this is the point where I said earlier, please don't hate me for that, but I started my career in the Microsoft developer stack. I know this is a Java user. I'm sorry, please don't judge me for that, but I started out, like, as I mentioned, in Amiga Basic, and then like C and C++. Also, early on, like some Visual Basic 3 and Visual Basic 4. For the younger people here, are probably like, oh my gosh, all these legacy tools, we stopped it. But, then I went into C, C++ and C# and worked in that area for quite some time. I guess it's just a matter of, whatever you start working on, you got to stick to the environment. But of course, over the course of the year, I worked in pretty much not any, but a lot of different technologies. I am with the Relic since 2017. The talk that I'm doing today is using the Relic as the backend, like the visualization. But everything that I'm sharing today can be applied to any other observability vendor. It's using pure OpenTelemetry. But I'll get into this in a second. And as you can imagine, looking at the picture, I like, if I'm not in front of a computer, I like all things outdoors, hiking, biking, climbing. This is also actually our skiing area where my family and I have 3 kids go. This is like maybe 15 minutes away from my place. So we have season pass and enjoy skiing in this area. And hopefully it opens soon. We got some first snow on the mountains already. So I recently asked ChatGPT, and this is the last, we have another slide, but I asked it, based on what you know about me, draw a picture of what you think my current life looks like. So you may know that ChatGPT has some memory function, remembers what you asked, if you prompted, and what you're working in and stuff. This is the response I got back. Here's an illustration capturing your world of life, inspired by the Bavarian Alps and stuff. And the picture I get was this. And I thought this was amazing, right? Because you can see already in the window, right, the Alps, pretty similar to what you've seen previously. You see also the houses there look pretty typical for the area I live in. It even, drew some desktop and some monitors. My little daughter, she then asked me, how does ChatGPT know that you have so many monitors at home? I don't know. I mean, maybe yes, developers have a lot of monitors. But what I also found interesting is that it drew some observability dashboards on the monitors as well. And I think this is just an amazing feature. I added the next slide in because I didn't know when I got here that this is actually going to talk at a university. So I was a little bit surprised. I actually came in from Boston just this morning where I did another event. And basically, I studied at Boston University at some point. This is a picture I took, I think, on Sundays. When I went back there, this is at Boston College. And, this was 30 years almost ago when I started there. But, it was a great time being back in Boston. Anyways, who in this room uses or has used Kafka before? Okay, one. Why? Because we also at Relic we use Kafka heavily. We used to have our own implementation, our own system of running Kafka. We moved on to a service that helps us manage Kafka. We use Confluent also recently. And just to give you some ideas on the amount of data that we collect, Relic is an observability platform, so we operate it as a pure SaaS service. And all of our customers that we use, they send in a lot of telemetry that we then store, upgrade, and provide some post processing. And so we process actually more than 15 million messages per second from all of our customers worldwide. And this is coming up on an average data rate approaching 1 terabyte per second. So it's a lot of data that we collect. And Kafka helps us really to process all of the data and make sure that our customers see some analysis of the data in close to real time as soon as they Since this is also sponsored, Olivia asked me to share like a promo code. If you happen to be in New Orleans later, this is a promo code that gives you access to their conference in Orlando later this year. So if you want to attend, you can use that. And since we are talking the promo codes, the Relic also has a generous free tier that you can use. No credit card required. You can just sign up using that link, and you get like 100 gigabyte of free ingest on a monthly basis. You can use this for your personal project. I also use this for my personal website and my blog and stuff like that. Anyways, enough talking. Who has heard about OpenTelemetry here before? Okay. Maybe like half of it. Who is using already OpenTelemetry in some shape or form? Okay. Well, nice. So I think this is a really interesting, standard that now evolves. It basically came from, 2 different other projects. As you may know, when we think about, telemetry from the applications, if you want to monitor your applications and services, you typically have different signals that you're capturing. You typically have metrics, traces, and logs that you capture. And our Relic agents that we built for various languages, they also did the same thing. We developed them over probably almost coming up on 20 years. But what's really nice about OpenTelemetry is it was a merger from 2 different other projects. OpenSenses, which focused entirely on the metrics signal, and OpenTracing, as the name suggests, on the traces. And so OpenTelemetry really combines these different telemetry signals into a single standard, which is nice because you can use one tooling, one environment to get up and running. What's nice about this as well, it is vendor agnostic. So you don't have to pick and choose what is your monitoring platform of choice. You can, set this up, use their APIs and libraries, or using auto instrumentation to get up and running. And then, choose later on and how do you want to handle the data? Where do you want to send the data to make some analysis on it? And it also standardizes the telemetry because it uses an underlying protocol, the OpenTelemetry line protocol, or OTLP for short, to define the data and how it gets sent over to different servers. What's also quite nice about OpenTelemetry is this pipeline. So it's considered the OpenTelemetry collector. And why this is important, and I have examples later on how that can actually be used. So if you remember this is a really interesting concept that OpenTelemetry also brings to the video. So first of all, as you can see here on the left-hand side, it also uses some language agents for various languages like Java, .NET, Ruby, Python. And you can use them to capture telemetry from your applications and then send them into this pipeline, into the receiver function. You can also define some other forms of receiving, like you get some data from your cloud environments, from your on-prem environment, from other forms of infrastructure. And also, put them into this pipeline. The second step is typically then some processing. So you can process the data in this OpenTelemetry collector before you actually export the data. And this is nice because you can then define, if I captured some data that I shouldn't export somewhere else, I can drop the data directly. Or if I'm using or captured some PII data, some personal information, some data that I cannot or should not store somewhere else, I can decorate the data, I can encrypt the data directly as part of this pipeline. And then lastly, of course, you can then decide and pick and choose for each of the telemetry types, metrics, traces, and logs, what do you want to do with it? Do you want to export it to some OpenTelemetry backend? Like, for example, in the Relic, you have a native integration or native API that supports OpenTelemetry, which is nice. Or you can also use some other open source tooling. Typically, there's Jaeger for tracing, there's maybe Elastic for logs, and Prometheus for metrics. But you have full control over the data and where to send the data to and how to process all the information. So again, this becomes important later on when I share some actual examples on how to set up and configure such a OpenTelemetry collector pipeline. So then the question is, hey, let's all jump into OpenTelemetry and get started, right? But there are some design considerations. And I have a couple examples in Java, not in .NET, that I use to show actually, what I mean. But in general, there's basically two things that you should consider when you get started. And I like that analogy of the cake because I like to eat cakes and cookies and all sweet stuff. But typically, there's two ways on how to approach this. So one approach is like the so-called zero code or auto instrumentation approach, which is here on the right hand side. It's basically if you want to eat a cake or a cookie, you can go to a bakery, look at whatever they have in store, and you can buy a cake. Right? The caveat is you don't have full control over what went into the cake. My daughter, she's allergic to peanuts, so I need to ask, are there any peanuts in there? Can I use it and get my family safe to eat that? But it's ready. I don't need to bake it. I need to have an oven. I need to have heating and heat up my oven. So it's easy to get started, but there's various level of control over what's happening. And then on the left hand side, the opposite. I could buy all the ingredients, put them together, heat up the oven, design my cake the way I want it. If I using pink or whatever color I like, and all the flavors. And this is typically considered manual instrumentation with OpenTelemetry. And I have some examples that actually showcase what I mean by that. So two different approaches. The one, I don't need to do anything to get started. Basically, I'm up and running in a couple of minutes. On the other hand, I need to put a little bit of effort in to get started. And also I have some dependencies in my projects. So next, it's also important to look into what is currently supported in OpenTelemetry. This is a screenshot, and I probably should update this. This is 2 years old when I first did the screenshot. They mentioned on the website on the docs of OpenTelemetry the current level of support for various languages that they use. So for traces, metrics, and logs, for Java, for example, this has been in a stable state for a long time. Java is probably the most mature language in OpenTelemetry, which is nice because this is a Java user group. But it's stable in the terminology of OpenTelemetry means that you can use it in production. It's pretty solid. There will probably still be some changes, but it's encouraged to use it in production. Using Rust, for example, this is like 2 years ago. I did this exercise again and again a couple of times. So they all went to a more stable phase, but still Rust until today is not like stable. So if you're using Rust, you can experiment, you can use it and evaluate it, but maybe running it in production is not encouraged. So then again, the exercise for Java, there's also a couple of libraries that you typically use, right? And they have these docs page also for other languages, but for Java, there's just this little bit, this goes on and on and on. Basically for all the different, all the various packages and libraries and frameworks. You should always consider, what packages am I using in a certain version, and is it supported yet or not in OpenTelemetry. In the case that I'm showing in a couple seconds, I'm using, of course, Kafka. So I'm using the Apache Kafka producer and consumer APIs, and they are already supported with OpenTelemetry. So ideally, I don't need to do anything to get started with OpenTelemetry and Kafka in Java. But I encourage you again, you look at the docs, they update and change so frequently. By the time I put this screenshot up, it's probably outdated already. So, but I encourage you to look into it, because whatever framework you use and it is supported, you will get a lot of deep insights into what is happening when using these frameworks and libraries. The example that I have today, where I'm using some instrumentation here, it's basically a pretty straightforward application. It has a front end, but most importantly, it has a producer written in Java. I use Spring Boot to get my application up and running, and it also has a consumer, and of course some Kafka in between. So I'm having the producer messages in Kafka, consumer reading from it, and then I have some other things that I'm doing. We call to a downstream service. This one here, and these other aspects, they are more focused on some other talk that I'm doing on AI monitoring. That is what this is for, where I'm using some AI, generative AI, and I'm using some automated quality checks for the responses, but this is a different topic. Anyway, so I have Kafka, of course, in between. All of them run in AWS. Doesn't really matter. I just went put them out there on an AWS App Runner instance. And this one is using Backup. So what does it mean for distributed tracing with Kafka? So I first will use the auto instrumentation or the zero code instrumentation. Again, I'm using the example of the Kafka producer and consumer example. This is the link that will get you to the docs and the QR code. So in general, if I want to start my Java application, I would probably start with something like this here in line 13, where I have the Maven wrapper and use the Spring Boot run command to get my application up and running. Pretty straightforward. But what I did here is I added in a couple more environment variables that I'm using to actually instrument my app with OpenTelemetry. So first of all, I'm using this OpenTelemetry Java agent. It's just a jar file that you can download from OpenTelemetry docs. You can download it, you can put it somewhere on your server, on the infrastructure, and then in the Java tool options, I just point it to the -Java agent and configure the OpenTelemetry Java agent jar file. So I don't need to make any code changes in my app. I don't need to get into it and add some dependencies and libraries. I just can use the Java agent at startup time of my JVM. Then also, I use the OpenTelemetry exporter, this OTel exporter OTLP endpoint, to actually define already where do I want to send the data. Remember this pipeline that I showed earlier, where you can export the data. This is where I'm telling the OpenTelemetry Java agent, please export all the OTLP, OpenTelemetry line protocol data to this API. This is actually our Relic endpoint for OpenTelemetry line protocol. And since this is an open API, we also need to add in an API key. Quite straightforward. In our case, we typically use the Relic license key for that. Again, if you're using something else, you're using some other form of observability tooling, this is where you can then adjust what you have to send the data to, and if you need to provide any API. So quite straightforward. This is probably done in a couple of minutes. I get up and running. It's quickly. And then as a result of this, I get typically, again, this is a Relic visualization, and other tools that may look a little different, but we capture metrics, traces, and logs from my application. We draw some map like this, where you can see I have a Java producer. It sends in some requests to Kafka, the producer consuming the consuming the messages from Kafka. Then I have a call, or basically two calls to my downstream service and one call to an external service, which is outside of my control. So this is just using JSON-placeholder.com. Anyone familiar with that? Just a sample, dummy website where you can ask for some dummy data, basically. And this is what I did. So that's that dummy JSON data. Yeah, it has, for example, you can do JSON based on the column/users, and that gives you a list of JSON users that you can use. You can say /user/1 to get, just it provides some dummy data. But I just use that because in general, all of these services here, the producer, the consumer, and the downstream service, these are all in my control. So I have written and implemented them. And I can add the Java agent, and this is what I did on all of them, right? Using the example that I showed earlier. And this is outside of my control. I cannot, put an agent on facing base over the top because I don't own it, right? But still, you get some, quite some good visibility into what is happening here, because I can see how many calls do we make to that service. What is the average response time and things like that? Do we see any errors? Is that side down? If I'm relying on this external service, it's maybe important information for me to look into, even though that this is a black box for me inside of what happens here. Any other questions? Yes.
So New Relic makes APIs to work with OpenTelemetry, which is a open source dynasty.
So New Relic basically started creating their own proprietary agents, similar to what we have seen with the OpenTelemetry Java agent. New Relic also has like a New Relic Java agent, a .NET agent, a Ruby agent, and they typically have APIs and SDKs in place, and you will, attach it to your application, and they will gather automatically some information from your services. In the case of Java, it typically does some bytecode instrumentation. So it injects some information into the headers of the methods that you're calling, and then there's some, compilation and timing and things.
Yes. On my angle, I work at a manufacturing plant.
Yeah.
And the databases, I forget what they're called, are like so totally bloated with data. Can New Relic filter that stuff down? And is that what some people use it for sometimes?
Yes. There's various ways on how you can filter. You can provide some drop rules and other kind of things to manage that data. And again, considering that OpenTelemetry pipeline specifically, you can even filter the data before you send it off to New Relic. Yeah. All right. So if I am now looking at a single trace, so a single, execution of, I send in some, request into my producer service. This will, create a message in Kafka, the consumer consuming the message, and all the things that happen behind the scenes. So this is a single execution, a single trace that we're looking at. In this case, in this example, this took like 6.5 seconds to execute. And what you can see here is typically this waterfall chart or this timeline view where you can see, what is happening, where's the time spent. I have the producer, the consumer, my downstream service, the external call. So all of this I can visually already see where's the time spent. In general, it looks like that in this parent span and in this span here, there's must be something happening. So the bars tell me the time that it took in certain areas of my application or in my architecture where the time was spent executing. And the color coding also tells me about the different services that I'm using, so they all have a meaning. What's also interesting, especially when you're using event-based systems, you'll typically see something like this here, like a blank space in a trace like this. And this is typically considered or named a consumer lag, because at some point you can see these green bars here, very small. This is kind of like the producer producing a message and sending it into Kafka. And then it takes a long time until the consumer picks up the message. So this is considered consumer lag. This is kind of like measuring the time on how long does it take for a consumer to pick up a message and process it after the message got produced into Kafka.
So this is also a very important metric that you want to observe in your event-based systems. Does anyone, it's probably hard for you to read, but does anyone spot something interesting in this, on all of these spans down there? Yes. This one here. So this is basically making a call to an external service. So it's just a different, all these colors, give me an indication of what service we remember this diagram here where, we have different services and applications. We try to put a random color on each of those so that we can differentiate them in a view like this. So it's just a different service, and it tells me that it's probably not worth looking into this section because it's very short and tiny. So the point is, or did anyone have a guess on what it is that looks interesting here? It's probably hard to read for the guys in the back. Yes?
I've seen words that say uninstrumented time, which I would be curious to know what that is.
Yeah. That's exactly what I was about to highlight, right? This uninstrumented time. And this is also already an indication of most of the time, like in this entire trace, 6.5 something seconds, the majority of the time, almost half of it, is spent in this section where it says uninstrumented time. That basically means that I'm using the Java agent of OpenTelemetry. It gives me some level of visibility into my app, but at some point, especially in my own code, it stops further instrumentation for various reasons, for performance reasons, for overhead reasons. It tries not to overload your application and provide too much overhead. So at some point, the auto instrumentation stops getting me visibility into my app. And in this case, very importantly, there's a huge block of time and I have no idea what is happening inside of it, right? And this is exactly what I wanted to point out. Yeah. So that's already showing the pros and cons. I was easy and fast to get up and running with OpenTelemetry using the auto instrumentation, but it has some limitations. And that brings me into the topic of manual instrumentation. So again, this QR code, the link brings you into the docs for Java specifically. And so in the case of the manual instrumentation, I'm not using oops, I thought I had another slide. But in this case, I'm defining similar things that I used to do in the run script at the beginning, but I do it in the application properties. Again, I'm able to define the OTLP endpoint where I want to export the data to that I'm capturing with OpenTelemetry. I also can define, in this case, the API key for that. But then I have to do some manual steps. As you can imagine, and I didn't have like a screenshot of the pom.xml, you have a lot of dependencies in your code. I added in a lot of libraries from OpenTelemetry into the application. And in this case, it's probably also hard to read, and it's not encourage you to read it, but it adds a lot of, I needed to add a lot of different things into my code, right? Which is, a little bit of effort. I can probably copy this or outsource this into like an external library, but I do have to have some dependencies in my code. And in this case specifically, one of the things that I can define here is some attributes, some resource attributes in here. I can define a so-called tracer provider, which allows me then to do some custom tracing and some custom information. But I do need to add these into my code, right? I do have to add some dependencies in my code. And again, finally, I'm building this OpenTelemetry object here where I have a tracer, a metric, a meter provider, and a logger provider, which allow me then to do some custom app things in my app. But also importantly, since I'm using manual instrumentation now, all the information that I was previously able to get with the interaction between the producer, Kafka, and the consumer, I also need to add in some so-called interceptors into the producer. So this is the producer interceptor, which I'm adding in the Kafka config in my app. And the similar thing I need to do on the consumer side. So this is a tracing consumer interceptor,
which basically intercepts the requests. So I didn't mention it at the beginning, but the way how it works is in tracing. And this is what we did at Relic, but also OpenTelemetry does these days. It adds some so-called W3C trace context in these as part of the metadata to these messages. So if you have like for example, an HTTP call from service A to service B, OpenTelemetry will automatically add some header information into the request that then the service B can consume. And similarly, when you do some event-based systems like Kafka, you also have some header information which will be added to every message that you put into Kafka. And then the producer will add this message, and then the consumer can consume this message. And this is what these consumer interceptors are basically doing for you automatically. So you don't need to write a code, but you can leverage them. Yes.
On the uninstrumented time.
Yes.
That's because you're using the canned vanilla version of OpenTelemetry.
Yeah.
And what you're doing with the manual is you're trying to fill that in to identify calls between servers and stuff like that.
Yeah. We'll see this in a second. Yeah. Yeah. But that's exactly right. It's the purpose for me on how why I wanted to show it is, it's easy to get up and running, but it has some limitations. And on the other hand, I'm using manual instrumentation. I need to put in some effort, more effort than with the auto instrumentation. But we'll see in a second on what the benefits are. Yes. Yeah. So then, again, this is a separate trace that I captured with the app instrumented using manual instrumentation. And again, this is one of the traces that took like 3.7 seconds. You'll notice that the consumer lag is a little bit shorter. That depends from trace to trace on the load of your system and so on. But in general, I can now see that there's similar things happen. But where we previously have seen the uninstrumented time using the auto instrumentation, I can now see some more information here on where's the time spent, right? I maybe have a method that I'm calling. I may have calls to other services, to a database, to other things. I can now see some additional information. Still, I'm seeing a huge block of a span here. Why the heck do we sleep here? But at least I know exactly where in my code I need to go and dive deeper into why it is slow. I literally do a sleep in the code here, so it's on purpose. But if you want to find out why it is slow and where it is slow, you have a lot more detailed information. But this also does not gets not captured automatically. You have to add in some code. And how does that code look like? For example, it could look like this, and there's various forms of how you can achieve this. And this is just one example where I'm creating some manual spans in here. And so remember, a trace is considered of a set of multiple spans. So I'm creating a manual span called execute long-running task here. Then I have another span that I'm creating, this why the heck do we sleep here. So I have good control over what it is I want to instrument. If I want to have some things like that in my code, I can really be very specific on how to measure my application. And out of all of this, I can then get detailed information of is it slow all the time? Is it maybe only in certain situations? Maybe only if I'm having some specific attributes or environments. I can even add in some custom attributes. So as part of this, I added in a custom attribute called seconds to sleep, which is basically some information that I can use then in my analysis to say how long did it sleep in the specific span. Why is this important specifically? So imagine you have some retail app where your end users can search for products on your website. They can put products into the cart. They can check out the process and purchase these products. If you then see like Black Friday, right? You have a lot of traffic and some users are experiencing some issues. If you then have some custom attributes like this as part of your instrumentation, you can then, for example, say, is it all the products that experience that issue in your cart checkout, or is it only a certain set of products? Because maybe only like a certain product category runs into an issue in the checkout. But having information like this, where you can maybe also put the product ID or the product category ID as part of some custom span, will allow you to have huge benefits in your troubleshooting and root cause analysis later on. So we looked into tracing, but then also the question is, how can we get some more details about the Kafka broker? In this case, so this is a view that I used for the producer side. So as part of OpenTelemetry, we will also capture some metrics, and there will also be some Kafka-specific metrics that we capture, and you can look into some metrics like the average I/O rate, compression time, the buffer used, similar metrics also for the consumer side, where you can see, incoming byte rate and, consumer bytes consumed rate, and a lot of detailed information, again, out of the box, just by using the OpenTelemetry agent. Then another question is, how can I get more visibility into my Kafka broker itself? So what we did until now is just looking at the application side and all of the different services. But if I want to find out how is my Kafka broker instance performing, this link brings you to the page for the Kafka docs specifically. And in this case, if you're running your own Kafka instance, as part of your boot up time of your Kafka broker instance, you can also point it to an OpenTelemetry Java agent, similar to what we have seen with the order instrumentation. And then this Java agent will then analyze also the Kafka application itself from an infrastructure perspective. So also easily to get up and running. Then you see some metrics from Kafka, how many messages consumed, and a lot of detailed information about this. The question now is, if you're not running Kafka in your own infrastructure, in your own servers, if you're running, for example, Confluent, which is a managed Kafka service in the cloud, so Confluent runs your Kafka brokers, in a managed environment for you. The caveat is you don't have access to this environment. You cannot install a Java agent into their infrastructure. But again, they have some ways in how you can receive metrics from their infrastructure. So they provide an endpoint that you can use to retrieve data from that cloud service that you're using. And this is where the OpenTelemetry collector again comes into play. Remember this pipeline that we looked at in the beginning, where we have the receiver, the processor, and the exporter. This is an example of a OpenTelemetry collector pipeline for Confluent Cloud. What we're looking at is have defined a receiver here, and this basically points to the API endpoint for Confluent. I also need to add in some Confluent API keys and so on and so forth, because it's not an open endpoint. Then I have a processor here. This is the middle step where I'm just doing some batch processing, so I'm not sending off the data directly to your backend. It is using some batching. And then also I have an exporter defined here. So the exporter again is leveraging in this case, our OpenTelemetry endpoint from the Relic and the license key. So really, straightforward on how to define this. And what's nice about this is that this concept of receiver, processor, and exporter will, is used in a lot of different environments. Once you have done that, you can also capture some metrics from the OpenTelemetry, from the Confluent cloud environment. You can put this onto a dashboard like this, where you can analyze the data. Of course, you can set up alerts and all the notifications as well. If you're using Apache Flink, which is another service that typically is being used when you use Kafka, so it's kind of like a job execution engine. Again, for OpenTelemetry specifically, they have a Flink metrics receiver. And the concept, again, is very similar to what we have already learned. When we define this pipeline, receiver, processor, exporter, it's the same process. I define a receiver. In this case, I ran this on my local machine. I have a processor where I'm doing some batch processing, and I'm also adding some custom attributes into it. And I have the exporter. So again, the same concept that applies. There's hundreds of these configurations out there on the public Confluent
on the OpenTelemetry contributors repository. Yes.
Use this to see why a server or a service went down.
Yes. Yeah.
And then be able to explain it to their customers. And, this is what went wrong. They can pinpoint
Exactly.
it.
Yeah. From a very much from an infrastructure perspective, why is Flink slow? Why is it not performing as expected? Why do we see, if we have our end users reporting, hey, my application is not running fast enough, we can then look at the application side and all the services, but we can also look into the infrastructure side. Is it maybe the infrastructure? Is it the applications? Is it some external service? So deep visibility, and you can do some analysis of why it is slow or not performing. Yeah.
It happens that the newspaper for Drew is called the Acorn, so that you're doing Flink with the squirrel is very appropriate.
And then again, once you do that, you get some, telemetry, some metrics from Flink environment. You can again put this onto a dashboard to visualize this data nicely. And this already brings me to the end of this presentation. In summary, I encourage you to, if you're not using some form of monitoring today, look into OpenTelemetry, get started, playing around with it, especially in Java. It is really mature. There's good support. There's a lot of open source projects that already have support for OpenTelemetry. If you are, using some framework, some library that is not supported in OpenTelemetry yet, you can contribute, right? It's an open source standard, open source project. You can get into the GitHub repository and contribute and make it better, and make support for OpenTelemetry happening. So it is really an open standard, and this is why I think it's a really nice way for us in the industry to capture telemetry in a vendor-neutral fashion. There's some links. I guess we can share the slides. Then we have the links to some reading material, the link to my GitHub repository, and so on. And with that, thank you very much, and I'm open for any questions you may have.
I think there's a statue of the author Kafka in Berlin or something like that. So did this Kafka thing grow up out of Europe and Germany?
That is a very good question that I don't have the answer to, but I think it was Prague, if I'm not mistaken, where the Kafka statue is. But it's, I may be wrong.
Prague?
I think in Prague, yeah.
Yeah, I think you're right.
Czech Republic, yeah.
Any more questions? No, anybody?
Oh, okay. So much like you're not a question, but a statement of many years in my life, I heard people iterate, comment on what gets measured gets fixed. And this is my first time seeing like measuring systems built for what I would call like the back end and the hidden stuff. I think that's really neat to get to see. And
yeah, in your instance, when you are capturing data from your services and processing it using Python pipelines, if you want to understand why your Python project is slow, why does it take so long to process my hundreds and tons of data, things like these help you get some visibility into that. Yes. Yeah. Yeah.
We've seen it in temperature sensors, pressure transducers. So getting to see it in a different world is interesting. It's the same concept.
Yes.
If you want to fix it, you got to measure it.
Yeah. Yeah. Exactly. Yes.
Yeah, I have a question. I remember at the beginning of your presentation, you mentioned you achieved like 1 terabyte per second. So that's a very impressive number. So like on what kind of like a cluster, like what size of the setup you achieved that?
Oh, that is a question I don't know. I mean, we have, basically we have two different regions that we use, one in the US and one in Europe. They have their public endpoint, and this is where all of our agents, all of our integrations send the data to. But I don't know anything about the infrastructure. But we do use, I mean, our most important purpose is that, you saw that if you're monitoring your services, your applications, we don't want to slow down your applications and add additional overhead. So what our main goal is, then you send in some data that you can send at any agent, whether you use the Relic agents or OpenTelemetry, they are able to send the data
off to us, ingest the data, and tell, hey, yes, I received it. But then we do some post-processing, right? As I mentioned earlier, we use Kafka. So what they do then is they receive the data, put it into a Kafka queue, and then do some post-processing. Basically, a list of Kafka brokers that all have some dedicated purpose. But the size of the nodes and infrastructure, I have no idea.
From the user point of view, as long as the metrics are received in a timely manner, that's
one thing that we measure. Yes, so you should be sending off the data and get it. Yes, I received it. You can go ahead and continue working, because as you can imagine, we work with a lot of video streaming customers. You can guess some of the names, right? And if you slow down the video execution, that is a serious issue. So that's what we don't want to do. So that's a number one priority. Send off the data to our backend, and then yes, we received it. You can continue working. Yeah. Yes.
Does New Relic work with Microsoft enterprise products?
So whether we internally or whether we support Microsoft enterprise products.
Yeah, the world I'm in is Microsoft, and I suspect there are rival products out there. And
oh yes,
if you want to bash them, you could, but it won't mean anything to me.
I'm not. I mean, it into bashing, no. But yes, I mean, there's always, and all of the major cloud providers, they have their own, kind of like monitoring environments. Microsoft has Azure Monitor, Azure App Insights, which does the same things. AWS uses AWS CloudWatch, CloudWatch Log, CloudWatch Metrics. Google has similar things. So they all have, some shape or form. These days, I think they're all going towards OpenTelemetry. Everyone, Microsoft, Google, Azure, AWS, for good reason, because we are all relying on a single standard, right? But where to send the data off to and how to analyze the data, that's a different topic. And I think we have some great support. In my opinion, there's other companies that serve the same market as we do as well. But I think the industry is finally relying on a single standard, which is nice, because if I'm if Confluent, for example, outputs the data in OpenTelemetry format, I can make sure that I don't need to process the data. I can directly send it off to my backend and analyze it, right? So that's really a nice advantage. Yeah.
Okay, I asked our folks checking in from other places around the world. There aren't any questions on YouTube. Anybody else? Okay. Well, let's thank Harry one last time.
Thank you. Thank you very much.
And I have just a couple of quick slides on what's coming up for us
Sure.
the next couple of months. So thank you. Here we are. All right. Where shall we? All right. So first of all, thank you, Harry. Thank you, Chris. Thank you, Logan. And thank you, Thomas, for spending the evening with us. Thank you for all of you, especially those of you who were here the first time. We hope to see you again. It would be awesome. So I'm going to limit, to what's going on. The ending slides here. So upcoming events. I just, even though it happened last week, the JCon at IBM Technology Exchange 2025, I was offered the opportunity to speak there. Long story, it's this didn't work out for us to travel to Orlando, but I hear a lot of great things about it. So this is the first time that JCon was in the United States. And then so there's some InfoQ and QCon events coming up. Actually, this week is if you want to get out to Munich real fast. So Harry might be there. So it's the Dev Summit Munich, which is this week, as I said. There is QCon San Francisco, which is the middle of next month. Always a lot of great topics. And QCon AI New York in mid-December. I'll be attending that one as a casual reporter for InfoQ. So this is brand new. So there might be some other QCon AI related conferences in other cities. And of course, it's trying to keep up with all the conferences. There was all the DevOps and everything else going on. So All right, just for us. So next month on November 11th, which is a Tuesday, Chandra Gunter, who is one of the co-directors here at the Garden State Jug, we'll talk about Maven 4. I keep looking to see when 4 is going to come out. They're in their second release candidate for the last couple of months. So I'm waiting with bated breath for that one. Hot off the press, and a lot needs to happen here. We need to make sure we have the room for that night. Eric D'Andrea from Red Hat or IBM, I don't know, they're interchangeable these days. It will be making a presentation in Hartford, Connecticut, and has offered to come visit us and New York. So that's why the 2 days are there. We haven't figured out which one. So this is all within the last 48 hours. So stay tuned for details on that. So that'll be the first meeting in December. The second one will be on December 9th. And this is going to be remotely from Ruggiero Robetti, direct from Dublin, Ireland. And he's going to talk about a product that's called OpenJ Proxy. He had to rename that because JDBC is an registered or whatever it's called. So anyway, and then in January, we have Bhupendra Mishra. We'll talk about the art of debugging in the era of AI. So with that, I didn't get a chance to see what our friends are doing. In order to make this happen, there we go. Okay, so we didn't have a meeting in August, and I really wanted to give our students a copy of IntelliJ IDEA. So we sort of, we didn't raffle one off for the month of September. The one for October came last week. So we have all 3 to give away. So, and by the time the next meeting comes along, we'll have a new license for the November meeting. So these are just some resources you can look at yourself. I know people register with Eventbrite, but sometimes people may register and may not be able to come. So to get more accurate attendance, if you could fill that out, we really would appreciate that. I have those QR codes out on the chairs, and that is it for us. Thanks again. Oh, thanks Diane for bringing the cookies today. So I forgot to mention that earlier. And then there's some pizza left. There's stickers. There's stickers from New Relic. There's some coasters, some Garden State Jug coasters. Impress your friends at home, for putting out a pint of good craft beer. And yeah, so with that, thank you very much. We'll see you in November.
Free audio post-production by alphonic.com.